Right. So next topic, reactions in solutions. See, for reaction to take place, reacting particles should collide with each other. And collision between reacting particles is possible only when reacting particles move. In the solid state, reacting particles are not mobile, they cannot move, they cannot collide with each other. Therefore, reactions are generally carried out by taking reactants either in the gaseous form or reactants are dissolved in a suitable solvent and then solutions of reactants are mixed together. It means we should know at least some of the concentration terms in which concentration of the solution in which reactant is present that is expressed. So write down. Wait a minute. Aaron, many reactions are carried out by taking reactants in the form of their solutions. Concentration of solution can be expressed in many different ways, some of which are, now we'll take up 4 concentration terms in 11th standard, but total there are more than 10 concentration terms. You'll study all these concentration terms in 12th standard. So we'll take up 4 concentration terms in 11th standard as per your syllabus. Number one, mass percent. See, if I dissolve sugar in water, then sugar and water, they are called components of the solution. So anything which is present in the solution, that is called component. Pattern, mass percent of a component in the solution is the number of grams of that component in 100 grams of the solution. 100 grams of the solution. Now note down the formula to calculate percentage of any component in the solution. Formula is component percent is equal to W component. W component means weight of the component divided by weight of solution into 100. Now you can note on here, always less than 100. Value of mass percent of any component will always be less than 100. And when we add mass percents of different components, that total will be equal to 100. Also write down, it is independent of temperature. That is, when we change temperature, mass percent of the component will not change. I'm sharing one numerical. We'll solve it. Check your WhatsApp message. And you'll find this numerical as numerical number Intext Numerical-24 in description box of this video. Calculate mass percent of methanol in a solution which contains 10 moles of water, 5 moles of methanol, and 1 mole of acetic acid. First of all, we'll convert these moles into masses. 10 moles of water. So weight of water will be 10 into molecular weight, 180 grams. 5 moles of methanol. Weight of methanol will be 5 moles into molecular weight, that is 160 grams. 1 mole of acetic acid. So weight of acetic acid will be 1 into molecular weight is 60. When we add all of them, this is weight of solution, and this weight of solution will be 400 grams. Now we have to calculate mass percent of methanol. So percentage of methanol will be weight of methanol 160 divided by weight of solution into 100, and this will be the answer. This will come out to 40%. 40% is the answer. Next, second concentration term, mole fraction. Mole fraction of a component, mole fraction of a component is the ratio of number of moles of that component to the total number of moles of all the components in the solution. Now write down the formula for calculating mole fraction. This symbol looks like capital X, but it is not X. This is called chi. If you write X, it's okay, but it's not X. Chi component means mole fraction of the component is equal to N component. N component means number of moles of that component whose mole fraction we want to find out, divided by N1 plus N2 plus so on. So denominator is sum of the number of moles of all the components which are present in the solution. Always less than 1. Mole fraction of any component will be less than 1. And when we add mole fractions of all the components, total will be equal to 1.
Sir, what does N1, N2 stand for?
N1, N2 is number of moles of all the components which are present in the solution. Their number of moles will be added, and that will be denominator.
Okay, sir. Thank you.
Yes, write one thing more. It is independent of temperature. It is independent of temperature. That is, when we change temperature, mole fraction of any component will not change. It will remain constant. I've shared one numerical. This numerical number 25 we are solving now. $400 grams of NaOH is dissolved in water to prepare 1120 grams of solution. Calculate mole fraction of NaOH in the solution. Now, for calculating mole fraction, we need number of moles of different components. So first of all, we'll calculate number of moles. Number of moles of NaOH will be 400 grams divided by molecular weight, 10 moles. Number of moles of water. See, total solution is 1120 grams. 1120 minus 400 grams is NaOH. That will be weight of water. So water is 1120 minus 400 divided by molecular weight of water. This will be number of moles of water. It will come out to 40 moles. Now, chi NaOH. Chi NaOH means mole fraction of NaOH will be number of moles of NaOH divided by sum of the number of moles of water and NaOH. So denominator is number of moles of all the components added together. So this comes out to 0.2 is the answer. It's a dimensionless quantity. It has no units. Next, third concentration term, molality. Molality. Symbol for molality is small letter m. It is the number of moles. It's the number of moles of solute dissolved in 1 kilogram of the solvent. Dissolved in 1 kg of the solvent. Note down the formula. Formula is molality is equal to. Now here symbol B will stand for solute. A will stand for solvent. I'll repeat. B will stand for solute. A will stand for solvent. If I write WB means number of moles of weight of solute divided by MB. MB means molecular weight of solute into 1000 divided by WA. WA means weight of solvent. Weight of solute and weight of solvent both should be taken in grams. Otherwise, also in general, if units of weight are not specified, weight will always be taken in grams. B, weight of solute in grams. A, weight of solvent in grams. MB, molecular weight of solute. Now, this is what? This is nothing but NB. NB means number of moles of solute. Right? On the right hand side, there is no parameter which changes with temperature. So write down, it is independent of temperature. It is independent of temperature, doesn't vary with temperature. Now, I'm sharing one numerical on this. Yes, this will be Intext numerical number 28 in the description box. I'm sharing on WhatsApp. Numerical is 28 grams of KOH is dissolved in water to prepare 1278 grams of solution. Calculate molality of the solution. So molality will be weight of solute 28 grams divided by molecular weight 56 into 1000 divided by weight of solvent. We are given weight of solution, that is 1278. From weight of solution, we subtract weight of solute, that will be weight of solvent. So when you calculate, this will come out to 0.4. We'll write 0.4 m and will pronounce it as 0.4 molal, MOLAL when we pronounce 0.4 molal. Now we are coming to the last concentration term in class 11 syllabus. As I said, you learn many more in 12th standard. So fourth is molarity, MOLARITY, molarity. Symbol is capital letter M. Capital M. It is the number of moles of solute present in 1 liter of the solution. Present in 1 liter of the solution. Now write down the formula for this. It will be molarity is equal to weight of solute divided by molecular weight of solute into 1000 divided by V solution means volume of solution. And remember, volume of solution should be taken in milliliters. Milliliters means cubic centimeters. I'm sharing one numerical. This is numerical number 27 in the description box. So you should write this is CC. But before we solve the numerical, look here. On the right hand side, we are using volume in the denominator. And you know, volume increases with increase in temperature. So when temperature is increased, volume will increase. Volume increases means molarity will decrease. So write down molarity is inversely proportional to temperature. Is inversely proportional to temperature. Now, I've shared one numerical 27. We'll solve this one. 9.8 grams of sulfuric acid is dissolved in water to prepare 500 cc solution. Calculate molarity of the solution. Very, very simple numerical. So molarity will be weight of sulfuric acid divided by molecular weight into 1000 divided by volume of solution is 500 cc. Calculate, it will come out to 0.2 molar. We'll pronounce it molar. 0.2 molar is the answer. Now, related to molarity, there are two more formulas which we'll be using. Write down. See, if we have a solution and we add some more solvent to it, it will get diluted. It means its molarity will decrease. So how do we calculate molarity of the diluted solution after addition of some more solvent? I'll give a very simple formula. Write down. If a solution is diluted by the addition of some more amount of solvent, then molarity of the diluted solution can be calculated by using the formula. Note down, this is M1V1 is equal to M2V2. M1 initial molarity, V1 initial volume, M2 is final molarity, V2 is final volume. Now, one numerical on this formula. This is numerical number 28. Check your WhatsApp message. 2 liters of 6 molar solution of NaOH is diluted. It means initial molarity is 6, volume is 2. Diluted by the addition of 4 liters of water, calculate molarity of the diluted solution. See, final molarity we have to calculate. Final volume is not 4 liters. Final volume is initial volume 2 liters plus 4 more liter of water has been added. So final volume is 6 liters, right? Now when you calculate, this will come out to 2. So answer is 2 molar. Yes, further write on. Now imagine we have 2 or more solutions of the same solute and we mix them together. We have 2 or more solutions of the same solute and we mix them together. How do we calculate molarity of the resulting solution which is obtained after mixing? Write down next paragraph. If 2 or more solutions of the same solute are mixed together, then molarity of the resulting solution can be calculated by using the formula. Note on the formula. M1V1 plus M2V2 plus so on is equal to M final V final. So on the left hand side, M1 V1, M2 V2, M3 V3, they're all molarity and volumes of those solutions which are mixed together. On the right hand side, M final V final is the final volume, final molarity of the solution which is obtained after mixing. I've shared Intext numerical number 29 in your WhatsApp. We'll solve this one. Numerical is 200 cc of 0.7 molar and 300 cc of 1.2 molar solutions of NaCl are mixed together. Calculate the molarity of resulting solution. See, 200 cc of 0.7 molar, molarity 0.7, volume 200. 300 cc of 1.2 molar, 1.2 molar, volume 300. Remember one thing, volume of different solutions which are mixed together, for calculation, all volumes should be in the same unit. All in liters, all volumes in cc or milliliters, unit should be same, that you have to keep in mind. Is equal to M final we have to calculate, and final volume will be 200 plus 300, that is 500. When you calculate, answer will come out to 1 molar. Now, in this case, there's one thing which you have to keep in mind. Sometimes when you calculate by using this formula, you should be careful that answer of the final molarity will be in between molarities of solutions which are mixed together. Final molarity will be between 7 molar and 1.2 molar. Final answer can neither be more than 1.2, nor be less than 0.7. It's something like this. If we have 2 cups of milk, in 1 cup of milk, quantity of sugar is by chance more than we normally drink. In the other, it is less. And if we want to normalize the degree of sweetness, what we can do is we mix both the samples of milk and then we taste. After mixing, sweetness will be less than the one which was more earlier, and more than the sweetness of the other sample in which sweetness was less. So that you have to keep in mind. Answer will be in between these two molarities. Now, what we'll do is we'll combine these concentration terms with stoichiometric calculations. Concentration terms with stoichiometric calculations. Generally, molarity term and stoichiometric calculations, they are mixed together for calculations. And molarity, I'm writing once again. I'll write the expression for molarity again because this will be using frequently. Molarity is equal to weight of solute, molecular weight of solute, 1000 divided by volume of solution in cc. VCC means volume of solution in cc. And this part is nothing but NB, number of moles of solute. During the reaction, when solutions are mixed together, then solutes are reacting together. Solvent will not react. Solutes present in solutions, they will react together. It means we'll have to calculate number of moles of solute present in different solutions which will react. So for that, we'll be using this formula. I'll write here. So number of moles of solute will be molarity into volume in cc divided by 1000. So we'll be calculating number of moles of solute by using the formula written in the corner. Now, heading is concentration of solution and stoichiometric calculations. Nothing but numericals. I'm sharing next numerical. Yes, this is numerical number 30. Say 200 cc of 0.5 molar NaCl solution is mixed with excess of AgNO3 solution. Calculate masses of AgCl and NaNO3 produced. Molecular weights are given. So it is NaCl and AgNO3 gives AgCl plus NaNO3. First of all, we'll calculate starting number of moles of reactants present in these two given solutions. It's clearly mentioned in the numerical is mixed with excess of AgNO3 solution. So there's no need to calculate number of moles in this case, and no data is given. NaCl is 200 cc 0.5 molar. I'll use this formula. Number of moles will be molarity. Molarity is 0.5. Volume is 200 divided by 1000. So number of moles will be 0.1. So we are starting with 0.1 mole of NaCl, excess of AgNO3, and actually there is no product in the beginning. Last time I told you about limiting reagent. Since this is in excess, this is the limiting reagent. So all calculations will be based on the basis of sodium chloride. Number of moles consumed / formed. Since this is limiting reagent, out of 0.1, that is entire will be consumed. This is in excess, no calculation will be required for this. Now coming to number of moles of products formed. This one is a very simple numerical. 1 mole gives 1 mole. 0.1 will give 0.1. 1 mole gives 1 mole. 0.1 will give 0.1. It means final number of moles will be, this will be 0. This is not to be calculated because this was taken in excess. Products will be final minus initial 0.1, final minus initial 0.1. So 0.1 mole of both the products is formed. Convert into masses, for which you have to multiply by molecular weights. So weight of AgCl produced will be 0.1 mole. Molecular weight is given 143.5. So this will be 14.35 grams. One answer. Weight of NaNO3. 0.1 mole. Molecular weight is 85. So 8.5 grams of sodium nitrate will be produced. So this was a very simple numerical. The only thing additional which we learned is calculate number of moles of reactant present in the solution. Once you have number of moles, then calculations will be as we did in the previous class. Same type of calculations. Now, a few more numericals. Yes, this is Intext Numerical number 31, which I've shared now. It says 100 cc of 4 molar NaOH and 300 cc of 1 molar sulfuric acid. Let me write equation. 2 NaOH plus sulfuric acid gives Na2SO4 plus 2 water. 100 cc of 4 molar NaOH. So starting moles will be 4 molar into 100 cc divided by 1000. This will be 0.4 mole. 300 cc of 1 molar sulfuric acid. 1 molar 300 cc divided by 1000, 0.3 moles. So we started the reaction with 0.4 mole of NaOH, 0.3 mole of sulfuric acid. Now, let me ask you one thing. Which of the two reactants is limiting reagent?
0.3.
Name the reactant.
H2SO4.
No. See, this one. 0.4 divided by stoichiometry.
Oh, yeah.
0.3 divided by 1. Stoichiometric is 1. I use the term stoichiometric amount for that. So number of moles divided by stoichiometric coefficient will be stoichiometric amount. That reactant whose stoichiometric amount is least, that will be called limiting reagent. So in this case, limiting reagent is NaOH. Number of moles consumed and formed. This will be completely consumed because this is a limiting reagent. 0.4 out of 0.4 consumed. Now calculation. 2 moles will consume 1. 0.4 will consume 0.2. Simple unitary method. 2 moles will produce 1. 0.4 will produce 0.2. 2 moles will produce 2. 0.4 will produce 0.2. Oh, sorry, 0.4 will produce 0.4. Do I need to repeat anything?
No.
No, sir.
Okay. Now, final number of moles. This minus this, 0. 0.3 minus 0.2, 0.1. Products, final minus initial, 0.2, 0.4. Now, question is, calculate masses of sodium sulfate and water formed and mass of reactant left. So weight of sulfuric acid left, 0.1 mole into molecular weight 98. So 9.8 grams of sulfuric acid will be left. How much is sodium sulfate formed? Weight of sodium sulfate is equal to 0.2 mole into molecular weight is 142. 28.4 grams of sodium sulfate will be produced. Third, weight of water form will be 0.4 mole into molecular weight is 18. 7.2 grams of water will be produced during the reaction. Right? So these are 3 answers of the numerical. We'll keep on solving numericals. It's just practice. There will be a variety of numericals. Here goes the next one. Yes, check the WhatsApp. Numerical is two aqueous solutions containing 4.16 grams of barium chloride and 5.1 gram of AgNO3 are mixed together. Calculate weight of AgCl produced. In this case, molarity is not given. In this case, in this numerical, masses of solutes which are present in the solution, means masses of reactants are given. They will be directly used, converted into moles, and then we'll solve the numerical. Reactants are barium chloride and AgNO3. Barium chloride plus 2 AgNO3 gives 2 AgCl plus barium nitrate. Starting moles. 4.16 gram of barium chloride. 4.16 divided by molecular weight 208. This will come out to 0.02 mole. 5.1 gram of AgNO3. 5.1 divided by molecular weight is 170. This will come out to 0.03 mole. Now limiting reagent will be, okay, you try. Which one is the limiting reagent?
Sir, AgNO3.
Yes.
Yeah.
This is the limiting reagent. Now, number of moles consumed or formed. This will be completely consumed. 0.03 out of 0.03 will be completely gone. Now, 2 moles will consume 1, 0.3 will consume 0.15, right? Half of this. This side, 2 will produce 2, 0.03 will produce 0.3. 1 gives, 2 gives 1, and 0.03 will give 0.015. Now, in this numerical, we have to calculate only the weight of AgCl formed, so we'll not calculate the rest. So, number of moles produced, 0.03, because we are not concerned with the rest. So, weight of AgCl, number of moles into molecular weight 143.5. When you multiply, let me tell you, answer will come out to 4.305 grams. See, the only additional thing we are doing is we are using either masses of reactants, or we are using molarity and volumes of solutions which are present in the form of volume of and molarity of reactants in the form of solution. Now I'll take up just 2 more. I'll share both of them together, then we'll discuss. These are numerical number 33 and 34. I'm sharing together. We'll solve them one by one. Yes. These are last 2 numericals. Numerical number 33. Let me see reactants. Reactants are sodium carbonate and HCl. Equation will be Na2CO3 plus 2 HCl give 2 sodium chloride plus carbon dioxide plus water. Only CO2 is a gas, rest everything is in the form of solution, right? Now the numerical is 400 cc of 4 molar HCl. So starting moles will be 4 molar 400 cc divided by 1000, 1.6 mole is added to 127.2 grams of sodium carbonate. 127.2 grams divided by molecular weight 106. This will come out to 1.2 mole. In this case, limiting reagent will be this divided by 2, this divided by 1. Limiting reagent is hydrochloric acid. Now, calculate mass of sodium chloride and volume of CO2 formed. We have to calculate weight of this. We have to calculate volume of this. Number of moles consumed and formed. This is limiting reagent will be completely gone. 2 moles will use 1 mole. I'll repeat, 2 moles will consume 1 mole. 1.6 will consume half of 1.6, that is 0.8. This part. 2 moles will produce 2, 1.6 will produce 1.6. 2 moles will produce 1, 1.6 will produce 0.8. Water, we do not have to calculate, that I'm not using at all. Now, final number of moles. This minus this, 0.4, this is 0, this minus initial, and this is again final minus initial. Oh, we have to calculate these two. Weight of NaCl. 1.6 mole into molecular weight 58.5. So this will be the first answer. It will be 93.6 grams. volume of CO2 produced. Volume of CO2 produced at STP, of course. 1 mole of any gas will be 22.4 liters. So 0.8 moles will be how much? 22.4 into 0.8. So volume of oxygen will be, CO2 will be 17.92 liters. This is the second answer. Now, the last numerical, and with that we finish the chapter. This is numerical number 34. (300 cc of 0.1 molar aluminum sulfate and 500 cc of 0.2 molar barium chloride. Reactants are aluminum sulfate, barium chloride. Al2SO4 thrice and barium chloride will give barium sulfate. Sulfate are 3, it means this should be 3. Plus aluminum chloride, 2AlCl3. 6 chlorine, 6 and 6. Yes, balanced. Starting moles. 300 cc of 0.1 molar aluminum sulfate. Molarity into volume divided by 1000. This comes out to 0.3 mole. Sorry, 0.3 mole. 500 cc of 0.2 molar barium chloride. 0.2 molar, 500 cc divided by 1000. This comes out to 0.1 mole. Calculate the mass of barium sulfate formed and reactant left. We have to calculate this, and which of these two is left, that we have to calculate. Okay, last numerical. Tell me the limiting reagent.
Sir, won't both of them be the same? Because
this will be slightly more. Wait a minute. Let me check my calculation. 0.1, 300. Okay. And this one is okay. Now this will be slightly more than 0.03.
it will come as 0.033 if you take it that way.
This one?
No, sir, the BaCl2.
How much point?
0.033.
No, it's 0.2 into 500. Let me check.
Sir, but then you have to divide it by 3, right, to get the stoichiometric amount.
0.1 divided by 3 will be 0.033.
Yes, sir.
So this will be more. This is limiting reagent. Isn't it? Let me check data again. Correct. This is the limiting reagent. Number of moles consumed, formed. Limiting reagent completely consumed. 1 will consume 3, 0.03 will consume 0.09. 1 will produce 3, 0.3 will produce 0.9. This we don't have to calculate. Final number of moles. This will be, of course, 0. This minus this will be 0.01 mole. This is 0.09 mole. Calculate barium sulfate and reactant left. So weight of barium chloride will be 0.01 mole into molecular weight 208, 2.08 gram. 2.08. And second is barium sulfate form. Weight of barium sulfate will be 0.09 mole into barium sulfate is 233. This will give 20.97. These are masses of products formed. So it should not have taken so much of time. The reason being we had to miss 2 classes due to whatever reason. Otherwise, anyways, as usual, it took 8 classes, which it always does. Now the thing is, first of all, there'll be minimum 2 weeks break. I'll keep on informing you. I'll write the message in the group itself. And if we switch over to 1.5 hour class, you both say Wednesday is okay for you. But if again we keep Tuesday or Thursday, there are 2 problems. Number one, classes will be on consecutive days. 1.5 hour, next day also 1.5 hour. I think will be too much for children, at least. For a teacher, doesn't make any difference. Teacher teaches for many hours daily. It's okay for a teacher, but for students, I know it's difficult. But if we have it on one of the days is Wednesday, and if we keep the other day Monday or Friday, then
Monday and Friday will be really tough because we have around 1.5 hour class with Kakar sir already on both Monday and Friday. So
then what do we do? I know.
So can you check with your other students? Can you check with your other students on what they feel comfortable with, and then we can maybe check and revise it.
I have been insisting them to come for Tuesday, Thursday, Saturday, and that to 1 hour as you are attending now. That is the best. But they probably have joined bio and the physics somewhere, and their timing cannot be changed because it's a big group. If it is a group of 2 or 3 children, adjustment is possible. But they're joined a big group. Change there probably is not possible. That is the main issue. And if we can't even have Saturday, because Saturday your class with Mr. Kirker starts at 6:30. 6:30. And I have my class 12 batch up to 10:15 in the evening.
Oh.
That's the big issue. And I don't want to spoil Sunday. Neither mine nor yours. Sunday should be free at least. Oh, that is
so then we can do. Sir, is consecutive fine? Because then that will also be okay, I guess.
Which day?
Either Tuesday or Thursday, sir. With Wednesday.
Okay, I'll have to talk to others if they are ready. But I don't know whether they have. Will that be possible for them? Okay, I'll get back to you in the WhatsApp group only, right?
Okay, sir.
Okay, sir.
Okay.